Dear friends, welcome back to my video lecture series. In the previous video, we discussed how to classify the partial differential equations. So all the partial differential equation classified into three kinds. It will be elliptic, parabolic, and hyperbolic. So today's topic, we are going to discuss how to solve or how to classify the elliptic equation, how to solve it, what are the methods are available for that, everything we are going to discuss now. So come to the topic, elliptic equations. An elliptic equation, frequently occurring elliptic equation is Laplace equation. So we had the topic in the previous semesters also, Laplace equation. It is nothing but dou square u by dou x square plus dou square u by dou y square equal to 0, or it can be also written as del square u equal to 0, or u double x plus u double y equal to 0. It is harmonic. The harmonic concept also you studied this concept. Or instead of giving this one in words, they will give harmonic or harmonic. Everything will give the harmonic of u. Use harmonic. In that way also they will give. So these are the way we can represent the Laplace equation. So we are going to discuss now how to solve, how to get the solution here. Right. Using difference quotient. In the previous video, we discussed how to change the differential equations to different quotients. We discussed that one only we are going to do now. U double x. One is this, according to the different quotient, u double y will be this equal to 0. If you are simplifying k equal to h, because if you are taking the distance in x direction and h is nothing but, you know very well, distance in the x direction, k is nothing but distance in the y direction. So if both are equal, then what's going to happen? Then how to simplify this equation? So if both are equal, this can be written as 4uij, which is approximately 3 equal to represents approximately equivalent to ui minus 1 comma j plus ui plus 1 comma j plus ui comma j minus 1 plus ui comma j plus 1. It will be easy to understand. It's look like the lengthiest one. I will give you a graphical representation, then only you can get that idea. Right. So if you derive this, we can get standard 5-point formula. It's nothing but uij. Previous one I have shown already in the last slide. This 4 we are going to take to the right hand side. So uij is equal to 1 by 4 ui minus 1 comma j. For example, these are all the 4 points. This is ui comma j. So what about the right hand side one? It will be I plus 1 comma j. Left hand side I minus 1 comma j. I plus 1 comma j, I minus 1 comma j. Similarly, upper part is I comma j plus 1, I comma j minus 1. Average of the 4 points if you want to find this. This is what the formula. I will give you now graphical representation. Easily you can understand the concept. Right. Look at that graphical representation of standard 5-point formula. So I have to find the value of uij, this one only. Then what I have to do? I have to take this point ui minus 1 comma j and this point ui plus 1 comma j, ui comma j plus 1, ui comma j minus 1. In this is in x direction will be I, in y direction it will be j. So if you want to find this value, average of this 4 points, 1, 2, 3, and 4. Left, right, top, and bottom. Average of 4 points. This one only represents standard 5-point formula. I hope you understand now. Right. Similarly, we can derive the diagonal 5-point formula. Diagonal 5-point formula represents this equation. No need to confuse here. I will show you the graphical representation. Then only you can come to know which kind of easiest one is this. Look at that. UAJ is a similar thing. Previously, what we have taken? Left, right, top, bottom. Average of that one will be the standard 5-point formula. But we are not going to do this one now. So what we are going to do? Diagonal. You know very well diagonal. That's why they have given through 45 degree. So these are all the diagonal points. These are all the diagonal points. 1, 2, 3, 4. So average of this four values will give Uij. If we are getting any confusion, what I can do, if I'm writing this as A, this is B, C, D, E, then if I want to find A, it will be average of 1 by 4 value of B plus C plus D plus E. That's it. Average of the four values will give diagonal 5-point formula. Is it clear? Right. Next, Libman's iteration process. As I told you already in the introduction concepts itself, I told you that concept developed by Libman's only. Right. So what is the Libman citation process? It is same as standard 5.5 formula alone. Look at that. I minus 1 comma j, the left side value. This is uij, ui comma j. This is left hand side is ui minus 1 j. This one. Right hand side is ui plus 1 comma j. Lower bottom is it will be I comma j minus 1. Top is ui comma j plus 1. So the average of that four values only you know very well. I mean this symbol, plus symbol simply if you want to say. Plus symbol represents the standard 5-point. Multiplication symbol cross, it will represent the diagonal 5-point. Right. So Lippmann citation process is the same process of standard 5.5 formula only, but here we are going to do iteration. That's why power n plus 1. If you want to find the first iteration value, you have to give n equal to 0 in all the position. That's what the meaning here. So just write in that order. Left, right, what will be bottom and then top. So then only you can easily remember the formula. Left value n minus 1. Similarly, bottom value n minus 1. Left and the bottom will get n plus 1. Other two will get n power n. This power n plus 1 n, this bracket inside we are writing n plus 1 n, that and all iteration numbers, not some other thing, not the derivative or some other thing. Simply it is an iteration numbers. That's it. Important note here, it will take place in MCQs also. The error in diagonal 5-point formula is 4 times the error in standard 5-point formula. Is it clear? The error in diagonal 5-point. So error will be more in which one? Either it is in standard or diagonal. Yes, it is in diagonal 5-point formula only. Okay, good. Now I will explain this concept with an example. How to get the solution for Laplace equation. We are going to discuss the problem now. Right. U double x plus u double y equal to 0. So in this unit, we have to identify the problem with the help of the given differential equation only. Right. Solve, or in other words, they will give the method. They'll specify the method. Using that one also easily we can identify. Solve by Lippmann's method. They will give it. So instead of giving u double x plus u double y equal to 0, they may give del square u equal to 0, or they may give u is harmonic. U is harmonic. In that way also they may give. Right. So we have to solve this equation over the square mesh of sides 4 units. 4 units means what? First line, if we are having 0, 1, 2, 3, 4. That's what the meaning. Similarly, in y-axis also 4 units. Satisfying the following boundary conditions. What are the boundary condition? U value 0 at x equal to 0. U value 12 plus y at x equal to 4. U value 3x at y equal to 0. U value is x square at y equal to 4. Get that? Here y is varying 0 to 4. It's here. Y is varying 0 to 4. Here y is varying 0 to 4. X also 0 to 4. X also 0 to 4. Because they mentioned here it is a square mesh. Fine. So now how to do that? We have to draw the square and we have to divide the square into 16 subsquares of what about the length? 1 unit. Length means what? In h direction also the difference will be 1. That is h is equivalent to 1 x direction. Similarly, in y direction, k we will take that also equal to 1. That's what the meaning here. Right. Now come to this one. This is what the diagram. What is the first boundary condition? U of 0 comma y equal to 0. Am I right? So u of 0 comma y equal to 0, which will represent which line? First I have drawn the line. I will tell you how to draw the diagram first. X-axis, y-axis. This is 0 line. So we have to draw y equal to 1, y equal to 2, y equal to 3, y equal to 4 line. Similarly, x equal to 0 line will be this. Now what I have drawn now, x equal to 1. This is x equal to 2, x equal to 3, x equal to 4. That's it. This is what the square mesh. We divide a square into 16 subsquares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 subsquares we have divided. Now, what solve the differential equation means what? They have given the boundary values. Look at that in the diagram. You can see here. These are the boundary values they have given in the question itself. But we have to find the uh, uh, temperature distribution in the middle side also. It's a Laplace equation is nothing but it's a two-dimensional heat equation only in steady state. Two-dimensional heat equation means what? Um, it will be a rectangular plate. Sorry, rectangular plate or a square plate. It is a square plate. So corner boundary temperatures they have given. We have to find the temperature distribution of the plate inside the mesh point or grid point, they will call it as. So boundary temperature they have given, we have to find the temperature distribution inside the square plate. It is a square plate, two-dimensional heat equation it is. Dou square y by dou x square plus dou square y by dou y square is nothing but two-dimensional heat equation in steady state. Right. This one only I have given here in the diagram. Just listen. Right. What is the first boundary condition? This is x line, y line. What is first boundary condition? U of 0 comma y equal to 0. At x equal to 0, this was the first one. At x equal to 0, at x equal to 0, u value is 0. Whereas which is x equal to 0 line? You know very well. This is x-axis. This is y-axis. So in y-axis, x value will be 0. So this is what the line. First line will be x equal to 0. So you should listen very carefully, guys. If you do it in a proper way, thereafter there is nothing. It's very, very simple problem. We are not going to memory any formula or some other thing. So it's so simple. So u of 0 comma y equal to 0. So 0, 0, 0, 0, 0. What is the next boundary condition? U of 4 comma y equivalent to 12 plus y. This is what the second boundary condition. This one will be the second boundary condition. So u of 4 comma y equal to 12 plus y. That means what? Um, this u of 4 x equal to 4. This is what x equal to 4 line. X equal to 0 line. This is 0 line. This is 1, 2, 3, 4. Similarly for y, it is 0 line. 1, 2, 3, 4. Clear? Right. Now u of 4 comma y equal to 12 plus y. What do you have to give now? We have to give the values for y to find the boundary condition, boundary values. Give values for y in this equation. Y, what is this line? Y equal to 0. This is y equal to 0 line, this position. So give y equal to 0, it is 12. Clear? 12. Right. and y equal to 1. This is y equal to 1 line. 12 plus 1, 13. Y equal to 2. 12 plus 2, 14. Y equal to 3. 12 plus 3, 15. Y equal to 4. 12 plus 4, 16. Clear? Right. Two boundary conditions over. What is the third boundary condition? U of x comma 0 equal to 3x. This is what the third boundary condition. Right. So, what will be x comma 0? How to identify this? This will be the boundary. Y equal to 0. Where y equal to 0? In x-axis, y equal to 0. If you're having x-axis and y-axis, x-axis, y-axis. In y-axis, x value 0. In x-axis, y value 0. In one axis, another axis value will be 0. That is the thing. Clear? Right. Now we identify the boundary. Now give the values. X equal to 0. Give 0. Already we have written 0. Clear? So that clue I would like to give now. That's why uh, repeatedly I will use to say that do not skip the video because you can't be able to understand the concept. Whatever the clue we are giving or any tricks and the tips we are giving, you have to miss it. Okay? Do not skip it. Right. Now, give x equal to 0, 0. Already 0. So the boundary corner value should coincide. If you are interchange the boundary condition, easily you can identify you have done some mistakes there. Clear? Right. So 3, 6, give x equal to 1, 3 into 1, 3. Give x equal to 2, 3 into 2, 6. Give x equal to 3, 3 into 3, 9. Give x equal to 4, 4 into 3, 12. Already this boundary condition will satisfy. It will coincide here. That's it. What is the last boundary condition? U of x comma 4 equal to x square. So for all x, y equal to 4. Which is y equal to 4 line? This is y equal to 4 line. This line only y equal to 4 line. Right. Now give the values for x equal to 0. Where is the x equal to 0? I'm going to give. Which will be this is what 0 position, then it will be 0. The corner will should coincide as I told you already. Give x equal to 1, 1 square will be 1. X equal to 2, 1 square will be 4. X equal to 3, y square will be 9. 3 square is 9. X equal to 4, 4 square will be 16. The boundary value should coincide. Clear? That's it. This is the only thing, guys. Particularly why I have chosen this problem first here is they have given the equation alone. For the rest of the problems, they will give this diagram. This diagram, you no need to choose the boundary and no need to write the boundary values there. It's the only complicated problem there. That's why I have chosen this. Right. So now we have drawn the diagram and we have written the values. What are the boundary values they have given there indirectly with the help of the equation they have given that. From that equation we found the boundary values we marked in all the places. Now what is our aim? So we know the temperature distribution on the boundary. This is a square plate. So we have to find the temperature distribution interior of the lattice point. The intersection point will be the mesh point or a lattice point. They will call it like that. So take this one. This one is U1. Take this as U2, U3. Similarly, another one is U4. Middle one is U5. And this one is U6, U7, U8, U9. Clear? Right. That's it, guys. Thereafter, it's a very, very simplest one. Just listen. I hope you understand how to draw the diagram and how to choose the boundaries and how to write the boundary values also. Clear? Right. Now come here. Let U1, U2, etc. U9 be the interior points. Rough values we are going to find because we don't know we have to find the interior point values. So if you want to find U5, what is the formula we can use? Standard 5 point or diagonal 5 point. If you are using standard 5 point, this plus this plus this, the average of this 4 value. We don't know what is our U2, U4, U6, and U8. We don't know now. That's why for initial process, what I'm going to do here is I'm going to extend the line. So what will be, yeah, up to the end, because in the end I'm having the boundary values. So what I am going to take to find U5, average of the four values 0 plus 14 plus 6 plus 4. Is it clear? So in the initialization only we are going to do like that. Thereafter the standard 5.0 from the initialization it will vary. Initial 5 point, standard 5 point and diagonal 5 point both will come, but first iteration onwards we will use standard 5 point only. You can ask why we have to use the standard 5 point only in the first iteration onwards. You know very well because in the beginning itself, beginning of this video lecture, I told you one important note. Diagonal 5 point formula is the 4 times the error will come for the standard 5 point formula. So standard 5 point formula only having less error. That's why from the first iteration onwards, we are going to use standard 5 point formula. Good. Now look at that rough values. U5 I am finding. What will be? I have done that. If you want to find U5, that four corner values. What are the four corner values? This four values. 1, 2, 3, 4. Because we don't know the middle level U2, U4, U6, U8. This four we are going to take. Okay, fine. So the average of that one we are taking, we can find that value. Now we know the value of U5 and the what are the values we can find now? We have to find the interior values now. We should think in that way only, right? We can find U1. How can you find U1? Will you use standard 5 point formula? Will you use standard 5 point formula? Tell me. Standard 5 point formula, if you're using this, this, this won't work because U2, we don't know U2. Then what we can do? Tell me. Then what we can do? Tell me, guys. So we have to find U1. What we can do? The diagonal 5 point we can use. So this four values. So 0 plus U5. U5 just before only we found rough value, initial value. 0 plus 4, 0 plus U5, diagonal 5 point. Similarly, I can find U3. How can I find? U5 plus 16 plus 4 plus 14, diagonal 5 point. Similarly, I can find U7. This plus U5, 0 plus U6, average of that four value. U7 I can find. Similarly, U9 also I can find. What will be? This plus this, U5 plus 12 plus 6 plus 14. That's it, guys. This is the way to find the rough values. I hope you have understand now. Clear? That's it. Now, so we know the value of U5. We know the value of U5 and U1, U3, U7, U9. Then what are the rest of the values we have to find now? U2. For U2, what you can do? So these values all are known now. So I can use standard 5 point formula for U2. Similarly for U4, standard 5 point formula. For U6, standard 5 point formula. For U8 also, standard 5 point formula. Clear? That one only I'm going to do now. Just listen. Yes. U5 rough value, diagonal 5 point formula I'm going to use for U1. Alright. What is U1? We are going to use diagonal now. This plus this plus this divided by 4. So what will be? Right. So U1 equivalent to 1 by 4, 0 plus 6 plus 4 plus 0. 6 is nothing but U5. This U5. right? Now, similarly, u1 we know. So u3 also we are going to use diagonal 5-point formula. So if you're using that, we can get 10. Then u7 is equivalent to 1 by 4. What is u7? I will show the diagram, then only easily can understand. u7 we have to use diagonal 5-point. 0 plus u5 plus 0 plus 6. 0 plus u5 plus 0 plus 6. Alright. So look at that now. 0 plus u5 plus 0 plus 6. 0 plus u5 plus 0 plus 6. u7. It's here. 0 plus u5 plus 0 plus 6. What is u5? We found just before, it is 6. That's it. So we found diagonal 5-point for u1, u3, u7 and u9 also you can find that. What about for u9? You just tell me the answer for that. u9, how to do that? 12, yes, exactly, plus u5 plus 14 plus 6. 12 plus u5 plus 14 plus 6. 12 plus u5 plus 14 plus 6. u5 is 6. Yeah, equivalent to this. That's it. We found the rough value or initial value. We can write like that, initial values. That way also you can write it. Right. Now we know the middle value and the corner values. Middle value and the u1, u3, u5, u7 we know. Then we can find u2 with the help of standard 5-point. And so u4, u6, u8. So u4, u2, u4, u6, u8 also we can use standard 5-point formula. So what will be u2 standard 5-point? Look at that standard 5-point only. u4, u6, u8, average of that four values will give this. That's it. So u1 to u9 we found the rough values. Okay, right. Now come to the first iteration. First iteration onwards it will be standard 5.5 formula only. So what is standard 5.5 formula for u1? Tell me the standard 5.5 formula for u1. What will be? Right. For u1, you are going to tell the answer. I will highlight the place. For u1, we have to find standard 5-point formula. Right. For u1, it will be u2 plus 0, 1 plus u4 standard. Hereafter, first iteration onwards, everything standard 5-point formula only. So for u1, what I am going to do? 0 plus u2 plus 1 plus u4. Got that? 0 plus u2 plus 1 plus u4. What will give? u2, u4 value you have to take from the previous iteration. u2 and u4 you have to take from old iteration value. So 2.4. Now we found u1 value. And some other authors they will represent power 1. Power 1 is 5. First iteration. u1 power 1. If you want, you can write. Or here we have given the title first iteration. That's why no need to write the powers also. Right. So u1 we found. Next, what you have to find? u2. u2 how it will be? Standard u2 standard 5-point formula. It will be this value u1 plus u3 plus 4 plus u5. u1 plus u3 plus 4 plus u5. Then what it is? That's it. u2 is equivalent to u1 plus u3 plus 4 plus u5. So just listen very carefully. Previous values, everything we have taken u1 plus u3. We have taken from the old iteration. Sorry, that what are the values are there? u1 plus u3 plus 4 plus u5. So u3 and u5, we don't know the recent values now. u4 and u5, we don't have now. That's why you have to take from the old iteration u1. Look at that u1 I didn't substitute here. Why? u1 we have recent values. So it's look like Libman's method is look like in MCQ they will ask guys. Libman's method it's one of the it's look like Gauss-Seidel method. In the first unit you studied Gauss elimination, Gauss geography, Gauss-Seidel. So it will be Libman's method is the one kind of Gauss-Seidel method. So in Gauss-Seidel method, we will use the recent values. So while you're solving for U2, what are the value for U2? U1, U3, 4 plus U5. So for U5, we don't have, for U5, we don't know the recent value. For U3, we don't have any recent value. But for U1, we have the recent value. That's why whatever the recent values are there, we have to take. U1 is 2.4. Other values you have to take from the old iteration. That's it, guys. Find the value, it is 5.6. Now go to U3. What about U3? U3 is U2 plus 15, 9 plus U6. So U6 we didn't find now. There is no recent value. So you have to take from the old iteration, initial iteration. And then U2 we found just before. That one we have to take here. Look at that. U6 you have to take from the old iteration. U2 just before we found the recent value. That one only. That's it, 9.9. Similarly, we have to proceed, guys. For U4, U5, that and all there. U5 we don't have. So old iteration from the old iteration, whatever the values we found in the first iteration, if it is new, take the new values. If we don't have any new values, take the old iteration values. That is a simple logic here. Right. So U1 new value we can take here. Right. So the answer will be 2.9. Similarly for U5, U2 plus U4 plus U6 plus U8. U6, U8 we don't have any new values. So apply take U6 U8 value from the initial iteration and U2 U4 from the first iteration. We can get 6.1. Then what about U6? U6 U6 here. I will show you here. U6. I have to find U6 now. What is U6? 14 plus U5, U9 plus U3. U9 plus U3, 14 plus U5. So what are the new values are available here? U3 available, U5 available. U9 is the old one we have to take from there. Substituted, we can get the answer average of that four value. It is so simple, guys. You don't need to remember any formula. Standard 5-point means this one, plus symbol, the four values. Diagonal, this is SF, PF. Diagonal 5-point in initial iteration only we will use. DF, PFS, diagonal 5-point formula is, if you're taking this value, this corner, this corner, this corner, this corner. That is product symbol. DFPF product symbol, SFPF plus symbol. Clear? Right. So we found the U6. Similarly, U7, we can proceed. So U4 recent value we have, we can substitute U8 initialization we have to take. U8. Similarly, U5, U7 recent value, U9 old value you have to take. To find U9, everything are here, new values. You have to take from this first iteration only, U6, U8. That's it, guys. This is the way to find the interior values in the first iteration. The same procedure you have to follow for second iteration. Look at that U1. What is the U1 means what? This plus this. I will erase it. Okay. What is U1 represents? The same formula. Already what you use for first iteration. Formula will be same. Values are going to that. So 0 plus U2 plus U4 plus 1. 0 plus U2 plus U4 plus 1. So U2 also we don't have new value. U4 also we don't have new value. This is second iteration. We have to take these values from first iteration. Do not go for initial, first iteration. That's it, guys. So proceed in the similar way for U2. U2 we have U1 recent value, take it and take other values from the first iteration. Then similarly U3, U2 we have from the recent second iteration itself, recent value. Other values are old values. So from first iteration you have to take. Similarly for U4, U1 is the recent one, U5 old value. I mean first iteration value you have to take. In U5 it will be U2 and U4 are recent values, new values which we just found. Other values are old one. So try to find U6. Similarly for U7 and then for U8. U8 what are the recent and old values? U5 recent value, U7 recent value, U9 only old value. Substituted 9.5. Then U9 will be U6 plus U8. What is U6 plus U8? U8 is 6.2 just before we found. U6 is already in the previous page. Substitute both. So this is the simple logic. Well, you're finding the value, particular value. If there is any recent values are there, take it. If you don't have recent value, go for the old iteration. I mean previous iteration. That's it. U1 is this. Then third iteration, second or third. So this is the important note I would like to give here. 9 interior points. At least try to solve up to third iteration. So what is the thing what we are doing here? This is iteration process. What we have to do? We have to check the first iteration value, compare the first iteration value, second iteration value. If both are same, we can stop the process. Until get the repeated values, we have to proceed here. So this is lengthiest problem. In the third and fourth iteration only it will converge, but it will be if you're a fourth and fifth iteration only it converge, but it will be very long. That's why it's better to stop in the third iteration if you're having 9 interior points. Similarly, you have the problem for 4 interior points. These are all points. For 9 interior points, go up to third, not totally 3 iteration. Initial iteration, first iteration, second iteration, third iteration, up to third iteration. For 4 interior points, try to solve up to fifth iteration. Whatever the value you are getting there, just write it. That will be the final answer. A little bit it won't converge, no issues. Up to five iteration, up to 5 iteration. Here up to 3 iteration. Not totally initial 1, 2, or 3 I have completed. Not like that. Up to 3 iteration, third iteration. Right. Similarly, third iteration also you have to proceed in the similar way. If there are any recent values are there, take it. If you don't have, take the old values. U2 recent we can take from this. U6 it will be old value. Similarly proceed for U4 and then U5, U6, U7, U8 and U9. That's it, guys. So just whatever you are getting in the third iteration, write the table at the value separately like this. U1 is 2.4, U2 is 5.6, U3 is 9.9, U4 is 2.4, U5 is 6.1, U6 is 9.9, U7 is 3.0, U8 is 6.2, U9 is 9.5. Whatever the value you obtain in the third iteration. Yeah, that's it, guys. This is the way to solve Laplace equation using Liebman's iteration process. I hope you understand the concept because I have given the graphical representation also to identify standard 5 and the diagonal 5. So I hope it's clear. Fine. If you like this video, share your friends and subscribe it. Thank you guys. Thank you.